We're gonna go
I
live.
don't think so.
We haven't met before. I'm sorry, but it's been a long time since.
No,
we've
I
done
don't think
this.
we have, but I also have a bad memory for people, so.
So, hello.
Hi.
Where are you located?
I'm in Berkeley, California,
We're live.
Oh, lovely country.
and we're live.
All right, I won't give out my address then. It's somewhere in the middle part.
Somewhere in the middle part. All right.
No, I live in Fort Worth, Texas.
Okay.
Yeah, somewhere in the middle part. Did you see that Elon Musk was suggesting that people consider moving to South Texas?
No, I hadn't seen
Because
that.
when I definitely think uprooting my life, I think I want to do that on Musk time.
Yeah.
He's probably doing that to stay in the good graces of the local communities and stuff to try and boost tourism. or
You're
something
gonna get
like
there.
that.
It's gonna be like 4 years before a house gets built.
I could be
Tent
convinced.
city.
I could be convinced. I'm trying to convince my wife to go to Texas for to snowbird in Texas. So
Yeah, come enjoy our freedom.
yeah.
I'm amazed that people
Yeah.
devote their lives to watching the Boca Chica site like 24 hours a day, apparently. Just
Oh yeah.
Well, there's a guy whose stream I watched for the last test who his house is right outside the exclusion zone, so he just lives there already.
Yeah.
And just sets up on his back porch and has this really elaborate streaming system now because he just
Yeah,
streams all the launches and he doesn't have to go anywhere.
there are eyes on that site 24. And
Yeah.
it's amazing when they do these 10-hour broadcasts for when Starship might go today, and they do a 10-hour broadcast. It's like that's dedication. I got an app that just alerts me in 10 minutes.
I mean, he used to live in the middle of nowhere, and then just suddenly this bucket of money opportunity fell on his doorstep, and just like raining from the sky.
Yeah.
Well, there's Boca Chica Mary, who same situation, and who has
There's
become
like 3 of them.
Yeah, and I mean, she has become like a phenomenal space journalist. Like it's incredible just by being out there every day and being able to cover the changes that are happening and being able to document them. It sort of gets right at the heart of what journalism is. So,
Right, not to put any of us down, but it's proof that anybody can do it.
Yeah.
If you don't need any background or anything. Anybody can do it if you just are willing to put in the
the time, the money, the
effort.
investment, and learn the trade. But yeah, and so she's gotten really good.
I think if they want people to move to Boca Chica, they need to set up starships for people to live in. Like, rather than blowing
cool.
them all up, they make
Right.
like a row of them, and that's your apartment block, and you're going to live in the top half of
Right.
Like an
SN11.
Airbnb, yeah.
If they ever
Oh.
have a starship that doesn't blow up by accident, then they can, because it's just like a cheap shell of it, right? So they can, maybe the next test it won't blow up, and then they can repurpose it as a
Yeah, I
house.
feel like that was a low blow, Molly.
Well, maybe that's their plan all along, is they keep meaning to land them on the street. And they just keep missing and say, screw it. And
Wait a minute.
Hit the self-destruct button.
Okay, no, you know what? I think you are exactly right, which is that the plan on Mars, they're going to land these things and they'll turn into the living quarters for the
this is all
Martian
part of
colonists.
the
Yeah,
prototype
And so they should
stage.
practice in Texas. Each one, they launch once, they land, and then people move in.
Or it's like
I
a
think
new
you've nailed
type
it.
of mobile home on Earth. So instead of an RV that you drive,
Right.
you can just fly up. What is it, 10,000 feet?
Right.
And then you drift for a while.
Yeah.
Using whatever attitude control
Dave,
they have.
this is
and
your
then
future.
You land,
This
and you're
is
good
your
to go.
lifestyle.
Yeah.
Just
You
drift
just, you live
over
in a
to
crater for a
Spain.
while. The grass
There
will
you
grow
go.
back
And if it
eventually.
does use the whatever is it, the Sabatier process, where it's building methane right out of the atmosphere, and so you just have you
pull that
take,
carbon dioxide out.
Do that.
Yeah.
You need that.
Yeah, you take your Starship, you open up your solar panel, it makes fuel. When it's full, you move your house. Perfect.
We are spicy today.
Space RVs.
Space RV, yeah. Solved it. There we go.
All right, where's my paycheck?
So is anybody going to be signing up for this Dear Moon program?
No.
I haven't seen that yet.
This is the free trip around the moon.
I want to look at
okay.
that
No, I
glass
wanna-
bubble.
I
Yeah.
want
that
Pacific
glass
astronaut
nose
the
cone.
old-fashioned way.
Yeah.
Was this the one that was supposed to occur in 2018?
Oh yeah.
They're still chasing the date.
No, oh, never mind. Go.
We should do our job.
Let's do a show.
Okay.
I mean,
I think, imagine
chatting
that.
about
Let's
space is
just.
part of
All right.
We're all here.
All right. Hold on. Okay.
What a coincidence.
Yeah.
We all just happened to log into Fraser's Zoom room at the same time.
Exactly.
I thought tonight was.
And then he knocked the live button with his elbow. And here we are.
You're getting, this is the Clubhouse experience.
There you go.
Yeah. All right. Here we go. Hello and welcome to the Weekly Space Hangout for Wednesday, March 31st, 2021. I'm Fraser Kane, publisher of Universe Today. This week, no guest, so we're going to go deep into the news. We're going to talk about the fact that there could be an impactor still squished around inside the Earth's mantle. SN11 went boom. A new look at the event horizon around M87's supermassive black hole. An update on TESS's exoplanet count. A neutrino observatory deployed in Lake Baikal. And how much satellites are going to contribute to light pollution. Joining me this week on my screen right now, I got Dave Dickinson. Hey, Dave.
Hey, still here in Norfolk, still writing, still playing with giant binoculars. And I probably have them for another week or two before I assume I have to set them back.
It was like 2 weeks ago, I think, or you filled in and you showed us this.
This is 3 weeks, and this is actually the week I was scheduled for. So I filled in the last 2 weeks. So, so I had a mouse solar observing last weekend, and we had one teeny little sunspot. So we actually had something to show people. Of course, with a big, safe spot or solar filter on the front. But it's I figured I would get it out there and show it off to the public. I'll have it out Star Party Saturday night.
Yeah, here, I'm going to put you full screen so people can see. Look at that thing. It's from Explore Scientific, and they're 120 millimeter giant binoculars. So it's like they're achromats, so they're not triplets, but they give
two refractors side by side.
Two 5-inch refractors. The achromat gives it a little bit of a violet tinge to it, so it's not. If they made them with the triple elements, they probably would solve that. But then, of course, that would also triple the price too. So that's a lot of glass to put in that. So.
Yeah. All right. Oh, you saw we've got Molly Wakeland. Hey, Molly.
Hello. Greetings, sky people.
And we've got Dr. Morgan Renberg. Morgan.
Hey, Fraser. I'm feeling a little emasculated by the binoculars. It's just
I saw somebody.
Like,
I saw a friend of mine in Tucson had two 8-inch Smith Cassegrains that he mounted on a chair. So he had a chair he could steer around with the binocular, basically too big. And binocular observing, there's also the problem of everybody that looks through it has to adjust the diopter distance because everybody's eyes are a little different. So it's a little complex using these with public viewing. Everybody's eyes are a little different.
Right, and you also have to change the
everybody has
slight difference in between your two eyes.
I have to give everybody a quick tutorial on feel free to refocus and readjust the diopter distance if you have to. So and you have to do that for everybody in line.
Interpupillary distance.
Nice. All right. Well, so before we get on with this week's news, I want to give a big shout out, of course, to our good friends, fans, executive producers at the Weekly Space Hangout crew, especially Nancy Graziano, but the rest of the team as well. They keep us organized. They bring on all of the really cool special guests that we have on the show. We couldn't do this without them. We wouldn't do this without them. So if you want to be a member of this amazing community, go to wshcrew.space and they'll hook you up. They'll give you your executive producer credentials so that you too can bring on special guests, unlike this week. So
an A+ to whoever's doing SEO on the WSH Crew webpage, because I typed Molly's name into Google and WSH Crew was the first thing to appear.
Really? That's surprising.
That's cool.
Yeah, or Molly needs to build a website.
I have a website. It just doesn't get enough traffic, I guess.
No, you got to use your whole name.
All right, everybody go to astronomolly.com so it'll boost higher up in the
You own your name, so that's good.
Yeah.
I have a tough name to own, especially since there's already another Dickinson that's a science writer out there.
Oh no, another. Yeah. Oh, that's rough.
Yeah.
I will admit, there's this girl on Twitter who's I think does planetary science reporting or something, who is also calls herself Astronomy, but I'm taking it over.
There you go.
Slowly but surely.
Oh no, there will be at some point there's going to be some kind of battle. Oh, this could get ugly. All right, well, Molly, you're on my screen, So let's start with you. Which of the stories would you like to talk about first?
Let's talk about TESS.
Yes, please.
It's a little less physicsy than the Neutrino Observatory, so I'll spare you the physics for a few minutes.
No way, we can handle the physics. But
Okay,
but definitely, let's talk about planets. This is such a wonderful number.
Exoplanets. Okay, so TESS stands for Transiting Exoplanet Survey Satellite. In case you don't remember what it stands for, I was talking about it last night on Explore Scientific's feed, and I couldn't remember what one of the S's stood for. It's satellite. Because they needed another S, and satellite, so why not? It launched in 2018 and is in Earth orbit. And over the last 2 years, it has been imaging, over the following 2 years, so 2018 to 2020, it's been imaging a good majority of the night sky, something about 75% of the sky, as opposed to Kepler, which was kind of focused on that one part of Cygnus. And it's been watching for dips in bright stars to be able to look for exoplanet transits via the dip method. I guess you could
transit
the transit method.
Transit method, searching for transits via the transit
right there in the name.
Yeah. I'm called the dip method. So in that time, it has identified 2,241 exoplanet candidates, and that's after the accidental ones have been removed from the count, like things that were from solar system space debris or issues with the camera, systematic stuff like that. So those are the ones that have a good chance of having exoplanets, but still need to be confirmed. Now, that confirmation step requires using another telescope to determine more characteristics about that star, possibly observe another transit, and that's done, for example, with the Las Cumbres Observatory network and some others. Now, only 120 have been confirmed of that 2,200 data set, but there's a lot of astronomers working on that, including a lot of amateur astronomers. This is something that you can get into as an amateur. Now, it's not as easy as Galaxy Zoo was, requires quite a bit of legwork, but if you're into working with computers, this is a good product for you. Last night's Explore Alliance Global Star Party, we had speaker Anna Para talk about that process, and it was pretty involved. It looked pretty cool.
When you think about it, so far, Kepler turned up 2,600 planets.
Just in that one square degree of sky, plus some stuff along the ecliptic.
Right, and as a comparison, you've got 2,200 candidate planets coming from TESS so far, and that spacecraft is going to last forever.
They've already extended its mission another 2 years out to September 2022, and barring any major issues with it, it'll probably be running for a good long time. So
we were talking about real quick. We were talking about. Go ahead. We were talking about
Dave Dickinson. Go first.
Real quick, we were talking about the EV scope earlier. Amateurs are using that to do follow-ups of exoplanet transits as well, right from their backyard.
So cool.
Yeah, because in addition to processing major observatory data, you can also use amateur equipment for some of the deeper dips and the brighter stars. I have a few data sets that I have yet to process that I'm working with NASA JPL's Exoplanet Watch program. I'm really behind on my variable star data, so I'm trying to get caught up on that first. I'm 2 months behind on processing my data.
So what's the process? If you want to actually confirm an exoplanet as an amateur, you can get access to the candidate planets and just start making your observations and try to participate. How does this work?
So if you're using TESS TESS observations and Las Cumbres Observatory, et cetera, observations, that process is data processing using software like Astra Image J. And there's a lot of parameters to fill out from databases, and then selecting comparison stars in the image, and some it's you're not sitting there doing any calculations by hand or anything, but there's a process to follow with us. The steps are all laid out to be able to make sure that it's that the analysis you're doing on that image is solid, and because you have to account for, since it's a ground-based telescope, variations in clarity of the atmosphere that would affect all the stars in the image, and that's taken care of during this process, and making sure that the stars you're using as comparison stars aren't themselves variable stars, which could throw off your measurement. But there's a whole step-by-step process laid out on how to do this, and you don't need any kind of massive computing power, just a willingness to learn a relatively complex but well laid out procedure.
And you don't need that powerful of a telescope. You just need to be able to do some photometry, right?
Yes, if you want to take your own observations, you can. I don't have a good sense yet on kind of what the minimum specs are for being able to observe an exoplanet transit. I think it depends on how deep the transit is, and because if it's only a couple fractions of a magnitude, your systematics may not support that. Like I'm going to discover whether my 8-inch f4 Newtonian and CCD camera are a good enough combination with this a couple of data sets that I haven't yet processed.
Right.
But yeah, it doesn't need to be some like meter class observatory telescope. There are people on the in fact, I think the Exoplanet Watch program, I think they're using AAVSO net telescopes, which are 8-inch, 10-inch, 12-inch class reflectors. So nothing really elaborate.
Right.
Kind of elaborate. If you're an astrophotographer, you probably have what you need to.
That's what I was thinking, yeah. And so TESS is the one that's out there in space with a pristine viewing environment, but actually a pretty small set of telescopes. It's not like it's bristling. It's not like it's Hubble or even Kepler. It's got pretty tiny little telescopes on it, and it's just finding those dips, but free of atmospheric issues, and so it can very reliably notice a change in brightness of one of these stars and then pass these along. And then observers here on Earth can just do observations for hours, days, weeks.
Yeah, and
months.
TESS is actually less sensitive than Kepler, and this allows it to access the brighter stars that would blind Kepler's cameras. And those brighter stars are the same ones that are easier for us amateurs to access. From my 8-inch f4 Newtonian from here in my Bortle 7 site in California, my limiting magnitude tends to be about magnitude 15 or 16, depending on how good the transparency was. When I stack 5 60-second images, I think I've reached a little bit deeper with 2x2 on really good nights. I've hit as low as mag 17 in the IR channel before, which was exciting. That data set, I was like, ooh.
So hold on. So you've actually got a now we're rabbit holing. I can tell, but you've got a specific IR channel just on that telescope as one of your filters.
Yeah. So I have a set of photometric filters that allow me to do photometry. I think it's helpful to have at least like one photometric filter that matches like a standard photometric filter, because then the absolute magnitudes are easier. But I think for doing exoplanets, you're really only looking at the relative magnitudes. So using the same filter as, you don't need like a Sloan R prime filter, because you're just looking for differences in magnitude, not absolute magnitude.
So let's say that a person has they've got a Celestron 8-inch telescope with a pretty good mount. They spend about $1,000 to $2,000 on a telescope. They take it out to show their friends and family Jupiter, but they want to get involved in this. How much additional gear will they probably need to spend to be able to participate? Like a good camera and a photometry setup?
Yeah, and a lot of people, a lot of time having a CCD camera instead of CMOS is preferred, just because CMOS cameras can tend to be non-linear. But I think that some of the newer CMOS cameras that are coming out are a little more linear. I have yet to test my CMOS camera to see how linear it is, but I have tested my CCD camera. I have a QSI 583. and it was quite linear between kind of the lower end and almost saturating. So that was cool. The photometric filters, right now they're hard to get just because Astro Gear is very hard to get right now because everybody wiped out the whole market during the pandemic. So
bicycles
right now
too
are ridiculously expensive. But you can probably use some filters that you already have. Like if you just have a UV IR cut filter, it's probably good enough. But again, I'm not super deep into this topic yet, so I'm not sure exactly what they want. But reaching out to Rob Zellum at the Exoplanet Watch program, they have a Slack channel, and
maybe
that's
I'll
a good place to start if you want to take your own observations.
Yeah, that sounds great. Thank you. All right. Larry Beckham is wondering when we're going to talk about Starship. So, Morgan, why don't we talk about Starship?
Starship go boom.
Starship went boom. All right. Dave, what have you got for us? No. All right.
I mean, there's not a lot more to say. In a sense, I think probably most people know what happened. Was this yesterday or 2 days ago now?
It was yesterday. Yesterday morning, like really early.
Time is immaterial.
Yeah.
At 8 a.m. local.
It was Monday,
here in Texas.
Was it Monday? Yeah, you're right.
They launched Starship SN11, and it seemed to go up, and it got to the hover point. It did its hovering thing. It started coming down. It began to execute the sort of now famous belly flop, and then boom. Yeah. But that boom happened in the clouds, and so not a lot of good view of what happened.
It was very foggy.
It was really foggy. It wasn't a really great launch yet.
Yeah, kind of on the way up, some people are saying that it looked like one of the 3 Raptor engines was maybe on fire. And Elon has said that one of the engines wasn't performing correctly on the way up, but that shouldn't really have been a problem coming back down because they only need really 2 working and then 1 working engine to complete the landing. And so in a sense, I don't know, you could see this as a little bit of a step back maybe, where before they had been kind of, every previous time they had successfully executed the belly flop. And it was only at the kind of the last moment or after the last moment where something seemed to go wrong. And in this launch, they didn't get there. Okay. And so in true SpaceX fashion, they're just plunging ahead. So they've skipped the next few prototypes and they're going to a new prototype. I think it's 15. That has lots of changes across all sorts of parts of the rocket. And their hope is that one of those changes will have fixed whatever this problem was. Now they're going about it a little more carefully than that. They're going to try to figure out what the problem was. And then if it wasn't fixed by one of their changes, that'll delay the launch of 15. But otherwise, it seems like 15 could be launching like next week or something, because it's already basically ready to roll out to the pad.
Yeah, and I think after that, I think they're jumping to even higher numbers. Like I know they've got SN20 in the works, but I think this is surprise. I get the impression that this many catastrophic failures is a bit of surprise for SpaceX. I think at this point they were hoping that they would have multiple living starships that they would be testing on a various basis to sort of work through all of the bugs. And right now they're still just in complete.
SN10 was so close.
I know. Yeah.
So close.
Hard landing, bad legs.
I think, we're all kind of contrasting this against the process of landing Falcon 9, which seemed to happen pretty quickly, and they made a lot of clear progress time to time. And I think, nobody outside of SpaceX probably knows why this is being more challenging. But one important thing to keep in mind is that the Falcon 9, during all of those landing attempts, was like an operational, had to work for the commercial client thing. And so they had to build it to a much higher level of doneness before trying it. And even though landing wasn't part of the primary mission, the need for it to work for the primary mission surely kind of bubbled down to all of the other elements that affected the landing. And in Starship, we don't have that, right? They're not trying to put anything into space here. And so it could be that they've moved a little too fast even compared to what they did for Falcon 9. And they're not, if he's saying that SN15 is going to have hundreds of changes, well, I mean, how are they going to sort of be able to track which ones are the right ones? And that's distinctly different than how they did either Falcon 1 or Falcon 9.
Yeah, hundreds of iterations, hundreds of changes when you haven't gotten to a point where you feel really comfortable with the ones that you're changing from. Like normally when you're in software development, you try to just change one thing at a time, and you in fact rerun your entire code base to make sure that nothing that you had already done broke accidentally as you implement each new change. So to go and implement 150 new changes simultaneously, large scale changes,
There's an interesting alternative way of running tests that I've learned about, that instead of changing, one thing, testing it, you can reduce the total number of tests you have to run by changing multiple things, but doing some advanced analysis to correlate which part of that ended up being effective. So instead of testing each individual change, you test specific combinations of changes. That way you're running fewer tests. But then you're not 100% sure what caused the success, but you're like 85% sure.
But this is
some analysis.
For sure. But I mean, this is the classic, we see this all the time in the software world, where you think you've sorted out relighting your rocket engines, and then you're working on sticking the landing, and it turns out that a bug creeps back in. Some change you made with the software to make the landing work more successfully ends up causing the engine relight or the pressurization or whatever it is to go badly. And so you have to test the entire thing beginning to end. Anyway, we're all just armchair experts here, as they are actual rocket scientists.
One other way you could look at this, I think, is they've been so just astonishingly efficient and effective at building the things. Yeah. Like I couldn't build anything out of steel that fast. And you wonder if they are kind of a victim of that speed, in that, like, already when something blows up, the next one's basically done. And so rather than kind of thinking through all the things that might be fixed to fix that, they do the one most obvious fix and then launch it, because they already have 4 more in the pipeline. And so maybe that will get them there marginally faster, but they're going to expend just a tremendous amount of launch hardware to get there. Whereas if they just built it at half the speed and made twice the fixes in each one, they might save a lot of steel.
I think that's part of their operating kind of mindset, is while most other companies don't have the capital to be able to just throw everything at the wall and see what sticks, they somehow are able to throw everything at the wall and see what sticks. It's like you give a million monkeys a typewriter and eventually get Shakespeare out of it, right?
Yeah, it's possible maybe to go too far down that path, though. I think it's been incredibly effective for them, but it is possible the typewriter thing's a good analogy. You're never going to get Shakespeare out of a million monkeys. At some point, you have to think a little bit about what you're doing, and there seem to be maybe kind of teetering on the edge of what works for that in spaceflight.
Well, and I think last time you were here with us, Morgan, we were talking about the launch delays that have been pushed into Blue Origins with their New Glenn. That, a New Shepard has launched flawlessly and landed every single time, I think, but New Glenn is late, super late, and is going to be probably
they might be too far on the other end of the spectrum. But SpaceX circa Falcon 9 was sort of perfectly poised to actually have a working product, but also make these remarkable generational improvements while succeeding.
Yeah, that was crazy.
I think it's also important to remember that the baseline for most rocket launches is that you destroy your launcher. So, just already, they could put cargo in these things and fly them off into space, and they would still be the equivalent of every other launch company. It's the trying to land them, trying to nail the landing part. These things could just be smashing into the atmosphere, and nobody would be, it would be no different. In fact, probably still cheaper. I wonder if a steel Starship is cheaper than a United Launch Alliance, than an Atlas or a Ariane 6.
they might just be betting, expending all the money now on all the testing, on the fact that they're going to make so much money in the future because they're going to cost less and therefore get a whole lot more customers. That might be a bet that they're trying to make.
Yeah. All right. Well, we could speculate all day, but you know what? We're just going to wait for SN15. Just make us proud, SN15.
SN100.
SN100. You've got this. All right, Dave Dickinson, what have you got for us?
Yeah, this interesting study came out. I was monitoring the 52nd Lunar Planetary Science Conference that was going on virtually over the last few weeks. And there was an interesting study looking at the Thea impactor, the hypothetical impactor that created the Earth's moon 4.5 billion years ago, they think. And there's a lot of indirect evidence for this, in that looking at you've got the angular momentum in the Earth-Moon system is very anomalously high. You've also got the mass of the moon and the Earth, and the fact the moon is receding slowly. We know from the laser reflectors on the moon that it used to be much closer to us billions of years ago, much visually larger and closer to us. That there's a lot of indirect evidence, but there's never really been any direct evidence as far as where did all that material for the Thea impactor go? As far as, did the core just merge with ours? Did the mantle actually merge down with our mantle? And something I didn't know, that there actually are two masses down in the mantle that they looked at in the study. And I'm going to say their acronym is very bulky. So I'm going to say it once, then we're going to call it blobs after that. The acronym is LLSVP, Large Low Shear Velocity Provinces is what these things are called. And there's two big ones on either side of the Earth's core, kind of like a pair of headphones in the mantle. One is under Africa and one is under the Pacific plate, under the Pacific Ocean. And they can actually get samples of these from the volcanic vents that are coming up through places like Iceland and down in Samoa in the Pacific. They can get gas samples from these. And they know from a lot of the isotopic samples of these that they date back probably right to about early Earth, about that same 4.45 billion years or so ago. Very intriguing that it's about that same time they think that impactor hit. Now, what this study posits is that these may be remnants of Thea that are embedded in the Earth. Yes, I thought that too. It really grabbed me. And as much as I'm like, I know I'm going to torture my brain to write about planetary geology, but I pitched this to Sky and Telescope because I was like, this is cool. And it's not really being reported a lot. So the study incidentally came out of ASU, Arizona State University. And they looked at two lines of evidence that is putting this forward. One is modeling it and looking at how would something stay down there that many billion years and not just get mixed into the mantle? How dense is it? How large would the impactor have to be? And the second thing they looked at is samples that were brought back from primarily Apollo 15, but some of the other Apollo missions, looking at the deuterium to light hydrogen ratio that's in these samples. And they think that if Thea looking at that ratio in there, they think Thea had to have been, we usually say Mars size, but they were telling me in the study when I interviewed some of the researchers, they're thinking more in the order of 4 times Mars size in order to have retained that light hydrogen. Now, there are problems with this. When they look at that and they say in those two lines of evidence, it comes down to that same density within a few percent that what they're seeing down in there. There's a few problems with it. One is the fact that the source of that hydrogen on the moon is from the surface, and they don't know if this is something that's been intermixed brought there. It could have been brought by other impacts. The moon's been hit by other things. There was a story a few years ago that went around that we all wrote about, that there's an idea that Thea may have kicked up 2 or 3 moons for the Earth, not just our one. And our one eventually absorbed those other impacts.
Right.
So that deuterium might have been brought there by, and that light hydrogen might have been brought there by cometary impacts. It might have been brought there by solar wind. What they'd like to do is get some samples from further down in the moon in the mantle that would see some of this remnant Thea, hypothetical Thea material. Does it still have this same isotope ratio of light to heavy hydrogen in there? Like Artemis wants to go to the if Artemis goes, which is still a go for now anyway, the South Polar region, the lunar Atkins Basin in the south. Viper is one mission that probably will go as a NASA rover that's launching next year, 2020, no, 2 years, 2023, we're 2021 now. So that is going to that area and going to sample, but that South Polar region, they think that impact region on the moon might be an example of the mantle that got exposed. And China's Chang'e 4 that landed on the far side, that is in that same region as well. I haven't seen what now their lunar sample return brought back younger material that was on the near side, but we haven't really sampled those parts of the moon. But I think it's intriguing that, and I talked to, there was Jennifer Jenkins, who's a seismologist at Durham University. They wanted a kind of a different perspective on this paper that wasn't on it. And she's like, well, there's some other ideas what these big anomalous blobs down in the Earth's mantle. We don't really have a good picture of them. What they're seeing, they see the shape and dimension of them from seismic waves they pass through the Earth. So we know they're there. They'd like to get a better resolution on them as far as their size and mass. And there's other ideas out there, but these are kind of cool if it were true too, that they think they may be tectonic plates that have piled up down there from subduction, which is almost as cool as thinking bits of Thea are still like embedded in our planet, in our side.
It is interesting to me how much, like when we think about like even just the fact that the continents are floating, are less dense regions that are floating on top of the mantle, and that's why they're on top of the mantle, is because they float, and that when I sort of imagine the interior of the Earth, and even the pictures that you see of the interior of the Earth, you just see these they're just these shells. The outer shell is the the outer shell is the crust, and the inside that is just these one color red, and then inside of that is a different color red, and it's all just this amorphous blob of rock. And I sort of imagine it as this rock goo. But to think that there are actual physical structures down there under the mantle, turning and tumbling and interacting with each other, and it kind of does make sense that if a blob of Thea went into the Earth and got sort of trapped inside, and it's just kind of being tumbled around and being moved about as it's being digested by the interior of the Earth bit by bit, as opposed to just we're so different than the other terrestrial planets in the inner solar system, and it all fits into that whole puzzle. I mean, we've got active tectonic plates, we have a large moon, we have our ocean on the outside. We're the only real liquid water ocean anyway. Morgan, you're our planetary scientist. Do you have an opinion? I know it's not, doesn't have rings.
Sorry, I got cut out there for a second. Can you say again what the question is?
Well, just the question being like, this sort of idea of large, undifferentiated blobs rolling around inside the interior of a planet. Is that?
I didn't know till I read the study that was even. I had never heard of the large low shear velocity provinces before. It was kind of interesting.
Yeah, it's a fascinating idea that there's these two pieces in there, and I don't know. I suppose it's possible. You imagine that the energy expended in the collision between Thea and Earth, enough to blast off the material to create the moon, certainly seems like it would have separated, to put it gently, the material from the impactor. But one of the things about giant impacts is that physics works weird when you get to those enormous energies. And sometimes things happen in a way that totally confounds what you would imagine. So I guess it's not impossible. This is not a ringing endorsement on my part. The idea that we can see, or we can study bits of that coming up to the surface, that seems ambitious to me.
Yeah.
You imagine all of the chemical and geological processes that go from this mass near the core all the way up to coming out an ocean vent.
That surprised me too.
And to imagine that you could somehow then correlate the specific, molecular properties of that material to link it to another celestial object. I guess it's not impossible, but it strikes me as something for which you're going to want to have some other angles on to say anything confident.
They said they would like some samples of the moon's mantle to like I said, there's some.
I bet they would.
There's some doubts as far as the Apollo samples, if we're seeing any other contaminants that, rather than, like I said, that would throw this estimate. It's intriguing that the estimates both match. But the jury's far from out on this one. I was talking to other seismologists and planetary scientists.
So we need to go back.
That's why things like Chang'e 5 that you mentioned are so important, because they are going to these big impact craters that might actually have access to that material.
Yeah.
That got younger material, if I recall, because I wrote about that one too. I don't know what the Chinese Space Agency kind of trickles out their information. So I don't know what kind of science they're getting out of that, but I know they went to an area that was explicitly a younger material than what the Apollo astronauts had brought back.
Yeah. All right, so I'm going to contribute a piece of news. I mentioned this at the outset, which is that a new study from the Royal Astronomical Society says that they've calculated what impact satellites and space junk could be having on the night sky, and they think that it could be contributing up to 10% above natural light levels across a large part of the planet. So, in other words, places that have absolutely no light pollution because of the satellites are actually starting to get some level of light pollution. So there's literally no place to hide around planet Earth.
So Fraser, are you pro light pollution or anti light pollution?
I have a Starlink, so I am. I'm pro human flourishing, anti light pollution. That's where I stand.
Spoken like a true politician.
Yeah.
I talked to a lot of satellite observers worldwide, and they are the mitigation efforts, like with DarkSat and the visor set they put up. They are lowering the Starlinks by magnitude or so, but people are still seeing them visually, and I still track them occasionally. I actually saw an amazing launch went out of the Cape 2 Sundays ago, came right up the East Coast at dawn. We had an amazing view. I think it was Starlink 21, 22, one of those, but it hit sunlight coming right overhead. So we can see Cape launches here in Norfolk. It's pretty amazing.
Yeah, I mean, one satellite pass is beautiful. One Starlink pass is a stunning thing to see in the night sky. Every time the International Space Station goes overhead, I stop what I'm doing and watch it go overhead. To know that even the darkest sky locations where they're trying to put telescopes are getting their night sky worn down by all of these satellites makes me sad.
Well, I tell other sat watchers, it's like whether you love or hate Starlink, it's important to document what's going on. So that's the approach I take. It's like, so if sometimes people come with their torches and pitchforks after me on social media, it's like I'm documenting what I'm seeing out there. I think that's important.
And I mean, I think the why this is so bad for telescopes is because they're placed in regions which have no light pollution. Like the battle against light pollution has already been lost. And I mentioned this, in the past, that if you have a problem with light pollution, that you should be outraged by how the fact that like a third of human beings can no longer see the night sky at all. Can see anything other than, they can't see the Milky Way naturally. They can just see a few of the brightest stars, and that's it. The battle against light pollution has already been lost, and the only saving grace is that we have these solitary places around the planet where you can put a telescope and it doesn't have light pollution, and you're not going to have airplanes flying overhead, and you're not going to have any radio telescopes getting interfered with, and so on. But satellites and space junk has to be everywhere, and so we're going to lose these dark places.
OneWeb is also quite far along with their constellation. They did their 5th launch this past weekend, so there's other constellations going up other than Starlink, and there's other ideas to do that too.
Oh yeah, and as always, I always say, right, like that if the price we have to pay for bringing the rest of humanity onto the internet is to do this, this is what we're going to have to do.
I hope the direction Starlink doesn't go is just because I think they know one of their biggest customers is going to be the U.S. Department of Defense, and I kind of hope that isn't going to be their only customer.
Yeah. But Elon Musk promised me on Twitter a couple of years ago that he wants to help provide space telescopes. So
when they get Starlink Mobile, I'll be in, because we travel.
Ordinarily,
non-pandemic, we travel a lot, and it's always getting internet and getting articles filed is always a trick when we're traveling. So.
People haven't been able to find the geofencing yet, so it's kind of already Starlink Mobile. Just, in theory, like I don't think you could take it to Canada, but I don't think you have a problem with taking it to within other parts of the United States right now. I suspect. I wouldn't take it back to Morocco. Yeah. So it's kind of great. It's absolutely the future. You could just you use it and you get it. And you're like, okay, yeah. I could live in a small town in the middle of nowhere and have Starlink and have high-speed internet and connect to the rest of humanity and educate my children online and get access to healthcare and all of that good stuff. And the astronomers are having the night sky ruined bit by bit.
It's already been a big discussion on the pandemic going around that there is an inequity, even in the U.S. You think not everybody has Wi-Fi. There's stories of kids having to do their homework in the McDonald's park. I've gone to the library here and sat outside during the pandemic just so I could use upload Dropbox, which is usually because their Wi-Fi was still on. I sat on the sidewalk to do Dropbox.
I have done the same. In fact, I have a story where I was driving with my kids in the U.S. one time, and it was maybe 10 years ago or something like that, and we were parked in a McDonald's trying to steal their Wi-Fi so that I could post a story to Universe Today, and just saying kids, there will come a day when Daddy doesn't have to do. Remember, you'll be remember when Dad made us drive around for 2 hours to find a Wi-Fi spot just so he could post a story. Yeah.
So I've kind of had the privileged experience of driving on the interstate after the solar eclipse in the passenger seat, tethering my laptop to my phone and posting pictures of the solar eclipse hours after it happened, right as I was processing my data on the interstate.
Yeah. You were the passenger, right?
Yes. Yeah, okay. I was in the passenger seat. Yeah. My eclipse buddy was taking a turn driving for a while.
But I think Dave put really put it in the right way, which is let's keep making these satellites darker. Let's keep mitigating the light pollution that we know we can do. Let's keep track of the space junk and bring it down and make sure that there's no excess space junk that's having to go and ruin the night sky. And let's also turn off all the lights in our cities. Come on.
Some of the Starlinks are already re-entering, because I track a lot of re-entries along with that. And some of them are already, so there's going to be an attrition where they're going to have to, once they get the constellation, just to keep it topped off, kind of. So they're talking a lot of launches for these things. Yeah. And SpaceX's cadence this year in 2021 has been really breakneck with Starlink. They've done a Starlink launch almost every week. That's incredible. They're keeping a very high launch cadence this year.
Yep.
And it's like a new industrial revolution where we weren't paying attention to smog and workers' conditions and stuff like that. Maybe we can learn from that this time around and try to be responsible in our planning of putting up these mega constellations. Dealing with the debris, dealing with the reducing light pollution, all the things that we in an analogous way didn't do right during the Industrial Revolution, right? We need to be taking that responsibility to plan ahead to mitigate what we already know is going to become a big problem.
Yeah.
Amateurs are going to need to launch their own space telescopes now.
Yeah.
And we'll be able to.
That's Musk's solution for people complaining about not being able to do astronomy because of all the satellites. It's he wants to just put up more space telescopes, put telescopes on the moon, which
put a small EV telescope on the back of every Starlink when it goes up.
Having more space telescopes. They get better views than we can here on Earth, but they're expensive. They're hard to maintain, obviously. And their time is so precious. Like here on Earth, we have a huge amateur community that does all kinds of science because we can just sit up in our backyards and image whenever we want, as opposed to fighting for time on the major observatories or on Hubble.
Yep.
So we would lose a capability, but I guess there's something to be said for having more space telescopes.
Yeah, but I mean, there's all kinds of really important reasons why we still need ground-based telescopes.
Yeah.
And as I always say, like, you cannot hug a space telescope. Like, just that alone, I think. All right, Molly, we've got time for one last story, and this is your specialty. So take us on a journey to Lake Baikal.
All right. So, as Fraser mentioned, I'm a PhD student. My current research is in neutrinos. And so it came across my Facebook desk, as it were, that Russia has deployed a new neutrino observatory under Lake Baikal. Now, Lake Baikal is an extremely deep lake, freshwater lake, and I think it's in Siberia or something on the eastern side of Russia. And it's extremely clear water, and it's deep. It's like a mile deep, something like 5,300 feet deep. So it's a joint project between Russia, Germany, Poland, Slovakia, and the Czech Republic. And it's called the Baikal Gigaton Volume Detector. We measure neutrino detectors in tons and kilotons and et cetera. And that's the amount of scintillator, that's the amount of liquid in it that is the medium for detecting the neutrinos. So gigaton is we usually talk kilotons, and so gigaton is a huge detector.
How does that compare, to like IceCube?
Yeah, so that's kind of the main comparison is IceCube, and I'm not sure. I didn't see offhand what the volume difference was in their scintillator volume, but one interesting advancement that the Baikal one will have over IceCube is that light scatters less in water than it does in ice. So they'll be able to have a higher angular precision. So when the neutrino comes in and interacts with material in the detector, part of what's produced are beta particles, which are electrons, which then produce Cherenkov light, which is that blue glow that you associate with nuclear reactors. And that's because the electron is actually traveling faster than the speed of light inside of the fluid, inside of the water. And it actually creates a cone. And by reconstructing the angle that the neutrino came in from that Cherenkov cone, you can know from where in the sky it came from to some 0.1, or right now in IceCube, it's a 0.5 degree, so about the size of the moon, angular resolution. Baikal will be 0.1 degrees, so it'll be an even smaller angular resolution. And this is all part of multi-messenger astronomy. So for centuries, we've been looking at just the visible light in the sky. And then in the last decade, we've now been able to look at gravitational waves. Well, now our neutrino detectors are becoming sensitive enough to be able to tell where neutrinos are coming from in the sky as well. And for example, supernova, they actually emit neutrinos before they emit light. So the neutrino signal reaches us before the light reaches us. So it's like an advanced warning system for supernovae. And so the next one that we see, we'll be able to slew the telescopes over to it with a more precise location and be able to catch the supernova on its rise as opposed to just seeing it on its fall. And that tells us a lot about the physics of what's going on in a supernova. Neutrinos also tell us about what's going on inside of the sun. And we're searching for this diffuse neutrino background, like the cosmic microwave background, looking for neutrinos from the birth of the universe. And that will tell us a lot about how the universe was formed. So there's a lot of fascinating science going on there. And having another neutrino detector, especially one with such an enormous volume, because neutrinos, they will plow through a light year of lead and only interact half the time.
So I just did a little bit of background checking while you were talking. Lake Baikal is 1,600 meters deep. It's considered the deepest lake in the world. A cubic kilometer of water is 1 gigaton. So it's going to be the same size as Ice Cube.
Okay.
And
I can't remember offhand how big Ice Cube was.
Yeah. And Corey S is mentioning in the chat that it's 5 times more sensitive than Ice Cube. So in your experience, water versus ice, that matches. Water's better than ice.
Yeah, and what the observatory is in this case, it's a lot like Ice Cube. They're sinking these glass and steel balls on cables down into the lake between 2,500 and 4,300 feet down, and the depth helps block out a lot of the sources of noise like cosmic rays and Earth radiation and stuff like that, so that they're seeing the neutrinos more often, or at least enough more often. They're not being drowned out by the noise of other sources of signal.
That's amazing. That's really cool.
The one downside of water, as opposed to like a liquid scintillator, like we have in other detectors, like the one up in Canada, is that the Cherenkov threshold is kind of high. It's like 2 or 3 mega electron volts, which I know probably doesn't mean anything to most of you, but it means that we can't detect as low energy of neutrinos as in other detectors. So this is mainly looking for galactic sources of neutrinos as opposed to like stellar sources of neutrinos.
Right. Very interesting. All right. Well, Molly, we've reached the end of our show. You're on my screen, so why don't you let people know what you're working on and where they can find out more?
So you can find me on astronomy.com, and that has links to my Facebook and my Instagram. I do a lot of astrophotography from my backyard here in the Bay Area, and do some scientific observing as well from my 3 telescopes set up in the backyard.
Awesome. Morgan.
Yeah, as always, you can find me at morganrenberg.com. I've got some new stuff coming out for SciShow, as well as on eos.org.
Terrific. All right, Dave.
Contributor for Universe Today, Sky and Telescope, also reviewing gear for Astro Gear Today, including these binoculars that I'm currently putting through their paces. At AstroGuys with a Z, Twitter is where I'm the most active. Although I've got my flag planted and all the things, I've also got 2 books. First one at the Universe Today, and the second one is our Deep Sky Field Guide. Just came out last summer, and I'm kicking around some ideas to pitch for a 3rd book. I'm thinking that there's not really any books out there on amateur satellite tracking that might be kind of an interesting. Yeah, that's kind of brewing in the back of my brain to start pitching.
I like that.
Among other things. So
yeah. Are we ever going to see a second printing of the first book? It's got to be.
I have Page Street. I assume they're still there. I haven't heard much from them for the last year. Which is
a ringing endorsement.
Yeah.
There are already we've talked about, like we're talking about the Hubble constant and things like that. There are already a few things that are in there that
zodiacal light.
I keep a running list of the very few tiny errors that have been brought to my attention, and some of the things that I would update if I had a chance in both books. So if there's ever an edition of either one, I have something ready to go.
Yeah. All right. Well, I'm just going to. We've got some upcoming interviews on the Weekly Space Hangout. This week, of course, was just our big news roundup, but. Next week, we've got Chanda Preska-Weinstein, which is going to be great. After that, we've got Dr. Ken Shen. After that, we've got Dr. Amanda Hendricks, Chelsea Goad, and then Dr. Tanya Harrison. So we've got a great all-star lineup. I've got a couple of interviews coming up on my YouTube channel. I'm going to be talking to Jesse Christensen, who runs the Exoplanet Center with NASA, and so we're going to be talking about the 2,200 new planets from TESS and the state of exoplanets. I'm also coordinating an interview with the folks at the James Webb Space Telescope. They just wrapped up their first list of all of the science operations that they're going to be doing, and so I'm going to talk to them just about sort of what's been selected, what are the first science targets they're going to be going after with James Webb, as well as some other interesting interviews coming up. So stay tuned for all that. I need your help, viewers, which is that I have to build a show reel of some of the interviews and stuff that I've done. And so I want you to tell me what's a good interview that I've done. What sort of shows me doing a good job being an interviewer? if you can pass that along, that would be amazing. Okay, on Slack, or just send me an email or whatever, so that I can sort of pull those together. Yeah, I'm just trying to put together a show reel for myself for just the work that I've done, and I just want to know which ones do I do a good job of? Where was I shining as an interviewer? So
Andy Weir was one of the most memorable ones.
That's the first one that jumped into my mind too.
Yeah, maybe. Yeah. That's a good one.
I didn't know you'd actually done that. I need to go watch that.
We've done 2 with Andy Weir.
Yeah. We're best buds with Andy Weir at this point.
That on the virtual Star Party, there was that time we didn't discover a supernova. That was kind of interesting. That wasn't an interview, but that was one of the more memorable highlights.
Yeah, absolutely.
I remember.
Yeah, totally. Okay, so I'm going to put everybody back on the screen. There we go. There's all of us. Thank you, everybody, for joining us once again here on the Weekly Space Hangout. We couldn't do this show without you. Again, I threatened we wouldn't do this without you, so you really make this whole thing possible. Thanks to all my co-hosts who have joined me again this week in their random configuration. It's always we were joking about this at the beginning. I'm the only one who gets to see everybody all the time, and they're always, they always have to kind of interact with each other in random ways. So it's I forget that I get to hang out with all of you every week, which is great. Thanks to Nancy Graziano for all of the coordination, and you saw that list of upcoming stuff that's all the great guests that are coming up. Thanks to all the moderators in the chat, people restreaming us over on Twitch as well. Really appreciate it. All right. Well, we'll see all of you next week. Thanks, everybody. Button. Got it. Oh, wait, did I? I'm pressing the end button. There it is. Okay.